Good morning students. Welcome back to your science class. I am going to take the combustion and fossil fuels lesson. In that a small topic called fuels. Okay. Before starting that fuels, we have to revise the previous day's portion. In the previous day, I have revised about how to extinguish a fire, and all the fires cannot be put out with water. For that only we are using the fire extinguishers. There are two types of fire extinguishers. Carbon dioxide fire extinguisher, in which carbon dioxide gas is used as a extinguisher, and soda acid fire extinguisher, and in this sodium hydrogen carbonate and sulfuric acid are mixed into separate compartments, and the carbon dioxide produced is used for extinguishing the fire. Then we have seen about what is a flame. Flame is a region where combustion of fuel takes place. Then the color of the flame depends upon the temperature and how much air is available and the nature of the substance that we are taking for burning. Then we have seen one more point, that hydrocarbons will produce or burn with blue or yellow flame. Then we have seen about that details about the different types of flames. Yellow flame is called as luminous flame, and it emits a lot of light. And this luminous flame is observed, that is, it experience incomplete combustion, and also it will leave some black residue. Then the blue flame is called as non-luminous flame, and it emits very little light. And the blue flame, it experiences a complete combustion, and blue flame only will emit a lot of heat. Okay. Then we have seen about the different zones of a candle. The different zones of a candle are the outer zone, the middle zone, and the inner zone. The outer zone is blue in color, and it is the hottest part of the flame, and it emits wax vapors with oxygen completely burned, and it emits carbon dioxide gas, and it also emits very little light. Then the middle zone is yellow in color, and it is hotter than the outer zone. Then it is accompanied by incomplete combustion of wax vapors, and we have here it produces carbon particles, and the carbon particles glow, and that's why the color is yellow in color. Also it emits the gas called carbon monoxide. Now this zone emits the most light. Okay. Then the last inner zone is black in color, and it is the coolest part of the flame, and in this zone the wax vapors remain unburned, and also there is no oxygen. So this region or the zone is completely dark, and it will not emit any light. Next we have seen about the combustion of a candle wax. While combustion takes place in a candle wax, we have to observe 4 points. The first one is the wick burns and it stands in a pool of liquid wax. Then second point is there is a small portion of unburned wick between the flame and the liquid wax. The third point is the liquid wax is trapped in a cup of solid wax. Then the fourth one is the liquid or solid wax never catches fire. So these are the things we have seen that day. Then today we are going to see a new topic called fuels. Now what are fuels? Fuels are the substances that experience or they undergo combustion in the presence of air or oxygen. Is it not? So most of the substances that are burning in the world, shall we consider as fuels? No, we cannot consider all the burning substances as fuels. Some substances may produce heat and light. Some fuels or some substances that are burning they are undergoing combustion, they will produce more than other energies, that is sound energy, other energy. So we cannot consider all the burning substances as fuels. So how to consider some burning substances as fuels? That is, if you find the applications, we can find out whether it is a fuel or not. Can you say some examples of fuels? Some commonly used fuels are wood, coal, cow dung, cakes, and kerosene, LPG, petrol, diesel, etc. Now, what is the use of these fuels? What are the uses of these fuels? Fuels are used for cooking, heating, then in automobiles, then for the generation of electricity, etc. So, fuels are the substances that undergo burning or undergoes combustion to produce heat and light and to produce energy. Okay. Now, most of the fuels or most of the substances, they are not used as fuels. Most of the burning substances, they are not used as fuels. The substances that produce heat and light and burning, we will call as fuels. And some of the fuels are coal, petroleum, wood, cow dung cakes, kerosene, LPG, petrol, diesel, etc. We use these fuels for cooking, heating, and in automobiles also, and for the generation of electricity. Now, let us see about the types of fuels according to their physical state. Based on their physical state, we can divide the fuels as solid fuels, liquid fuels, and gaseous fuels. Now we have to see one by one. First one is solid fuels. What are solid fuels? Fuels that exist in solid state at room temperature are called solid fuels. Can you say some example? That is wood, charcoal, cow dung cakes, agricultural waste, coke, and coal. These are the examples of solid fuels. So what are solid fuels? Fuels that exist in solid state at room temperature are called solid fuels. Example: wood, charcoal, cow dung cakes, agricultural waste, coke, and coal. Okay. The next type is liquid fuel. What are liquid fuels? Fuels that exist in liquid state at room temperature. That is, the fuels exist like water. Okay. So fuels that exist in liquid state or at room temperature are called liquid fuels. Now, can you say some examples of liquid fuels? Kerosene, petrol, diesel, and fuel oil are some of the examples of liquid fuels. The last one is gaseous fuels. What are gaseous fuels? Fuels that exist in gaseous state at room temperature are called gaseous fuels. Example: petroleum gas, natural gas, biogas, etc. Now, let us see about the characteristics of fuels. Now, what are the characteristics of fuels, students? All the combustible substances cannot be used as fuels. Already we know, is it not? So, what is the reason for this? Because fuels, they produce heat and light on burning. Some of the burning substances, they will produce other energies also. So, if you see the amount of energy produced and which type of fuel we are using, so it depends upon the cost or the price of the fuel, then how much efficient it is, efficiency, and how much available it is, that is, if it is more available or less available, and the extent of pollution, that is, whether it causes a pollution or it will not leave any residue. So according to that only we can find out whether it is a fuel, good fuel or not. Okay. Now, among all the characteristics, the important characteristics of a fuel is the calorific value. Now let us see about what is calorific value. Calorific value of a fuel is defined as the amount of heat produced in 1 kilojoules when 1 gram of fuel is completely burned. So when you burn a fuel, how much amount of heat is produced. Okay, so when you burn a fuel, 1 gram of fuel, if it is completely burned, and how much amount of heat is produced in that value will be the calorific value. So calorific value of a fuel is the amount of heat energy produced in kilojoules when 1 gram of fuel is completely burned. So for all the physical quantities, there will be some units. Like the same way, calorific value has the unit, that is kJ, kilojoules, that is kJ, it is represented as kJ, kilojoule. Then examples of fuels, any fuel's name, you can say any fuel's name. So examples of fuel, first of all, wood, coal, cow dung, kerosene, then agricultural waste, LPG, etc. Now these fuels are divided into 3 types according to their physical state, that is solid fuels, liquid fuels and gaseous fuels. Or solid fuels are fuels that exist in solid state at room temperature. Then example, cow dung cakes, agricultural waste, coke, coal, etc. Then the second type of fuel is called as liquid fuels. What are liquid fuels? Fuels that exist in liquid state at room temperature are called liquid fuels. Example, kerosene, petrol, diesel and liquid fuels. Okay, next one is, third one is gaseous fuels. Fuels that exist in the gaseous state at room temperature are called gaseous fuels. Example, petroleum gas, natural gas, biogas, etc. All burning substances are not used as fuels because although these fuels produce heat and light when it is burned, some of the burning substance may produce more energy than others. So the amount of energy produced and what is the fuel used and whether it is used as domestic or industrial use, all will depend upon its cost, efficiency, availability and extent of pollution it causes. Among all, the most important characteristic of a fuel is its calorific value. So calorific value is the very important characteristics of a fuel. Now, what do you mean by calorific value? Calorific value of a fuel is defined as the amount of heat produced in kilojoules when 1 gram of fuel is completely burned. Now, for all the physical quantities, there will be some units. Like the same way, calorific value also has some unit called kilojoules per gram. So, the unit of calorific value is kilojoules per gram. So, calorific value is expressed in kilojoules per gram. Now, the highest calorific value of a fuel is it will produce more heat. If a fuel has highest calorific value, then it is considered as the better fuel. Then calorific value of a fuel is low, means it is not a good fuel. Higher the calorific value, higher the heat produced will be. Higher the calorific value, the better will be the fuel. So when a fuel is burned by a machine, some of the energy will be given out as heat or given off as heat, or it may be wasted. Some energy may be wasted. So if that heat energy is utilized for cooking purpose, then it may not any waste. So the proportion of energy from a fuel that is converted into useful work by a machine is called fuel efficiency of a machine. So what is meant by fuel efficiency of a machine? The proportion of energy from a fuel that is converted into useful work by a machine is called fuel efficiency of a machine. Now still today there is no fuel which is having 100% efficiency. Some of the calorific values of some fuels are given in the tabular column. I will show you now. Now, wood pellets 17 kilojoules per gram, charcoal 35 kilojoules per gram, coke 33 kilojoules per gram. Then petrol 47 kilojoules per gram, LPG 50 kilojoules per gram, hydrogen 150 kilojoules per gram, coal 25 to 33 kilojoules per gram. Here there is a variation because it depends upon, or the calorific value depends upon the type of coal we are using, whether it is anthracite coal or bituminous coal or lignite coal. Then cow dung cakes 7 kilojoules per gram, kerosene 48 kilojoules per gram, biogas 35 to 40 kilojoules per gram, methane it is 55 kilojoules per gram, diesel 45 kilojoules per gram. Now this tabular column you can see the variation in their calorific values, but which is having the highest calorific value, that is hydrogen. Hydrogen is considered or hydrogen is consisting of 150 kilojoules per gram. So we can say hydrogen is the most efficient fuel, or hydrogen is the good fuel we can use, but it is not utilized in our day-to-day life, since the storing and transporting purpose is very difficult. Very care should be taken while handling hydrogen, so it is not used as a domestic fuel. Now let us see about some of the important characteristics of ideal fuel. First one is the fuel should have high calorific value and its ignition temperature should be low, that is, it should be above the room temperature. If the ignition temperature is too low only, the fuel will catch fire very easily, and if it is very high, the fuel has to be heated for a long time before it catches fire. Then the third point is the fuel should have moderate rate of combustion and should release heat in a controlled manner. Then the fourth point is it should be fairly cheap and easily available. A fuel may be having high calorific value, but if it is too expensive and it is not available, then how can we use? So it should not be very expensive, it should be cheap and easily available. Then if it is like that, then only we can use in our day-to-day life. Then it should be safe to handle, store and transport. Then the last point is it should not cause pollution on burning. Now, so these are the main characteristics of an ideal fuel. So what is the first point? The fuel should have a high calorific value. Its ignition temperature should be low but well above the room temperature. Why we have to see the ignition temperature means if the ignition temperature is too low, the fuel will catch fire very easily and sometimes it may cause danger in our day-to-day life. So if it is high calorific value, if it is very high, the fuel has to be or if the ignition temperature is too high, the fuel should be heated for a long time before it catches fire. Then the third point is it should have a moderate rate of combustion and should release heat in a controlled manner. Then the fuel should be fairly cheap and easily available. That is, the fuel which have a very high calorific value will be sometimes may be expensive and not easily available. Then so it cannot be used in our day-to-day life. So the fuel should be cheap and easily available. Then the fifth point is it should be safe to handle, store and transport. Then the last point is it should not cause any pollution on burning. So these are the important characteristics of an ideal fuel. Now let us see the different types of fuels we are using in our day-to-day life. First of all, hydrogen is considered as a best fuel since it has the highest calorific value, but it is highly inflammable, so it is very difficult to transport and it is very difficult to store and handle. So therefore hydrogen is not used as a domestic fuel. Then methane and LPG gas as a fuel. Then both methane and LPG have fairly high calorific values. They burn with smokeless fire, or they will not produce any smoke, and they won't cause any air pollution also. So methane and LPG gases are used as fuels in our day-to-day life. Then even they can be stored easily, they can be easily transported in cylinders through pipelines. So that is used for domestic purpose. Then the next one is petrol and diesel fuels. Both petrol and diesel are mainly used in automobiles. What is the reason? Their main disadvantage is very limited. That is, they are easy to store, they are easy to transport, etc. Then another disadvantage of this combustion is sometimes when you burn a fuel, it may release some harmful gases in the atmosphere. So when petrol and diesel are burned, it will produce some harmful gases into the atmosphere. So we have seen about the characteristics of ideal fuel. Then we have seen hydrogen, how it is used as a fuel, and methane and LPG gas, petrol, diesel, etc. Mostly hydrogen is considered as the most efficient fuel, but it is not used in our day-to-day life since it is very difficult to store, transport and handle, and easily or it will catch fire easily, or it is highly inflammable. It is not used as a fuel in our domestic life, but it is used for rocket fuel. Then methane and LPG gases, they have fairly high calorific values. Methane, it is the 55 kilojoules per gram, and LPG, it is 50 kilojoules per gram. So they are used in our day-to-day life. Also they have a use, that is the main advantage is it is easy to store, easy to transport and easy to handle. And the next one is petrol and diesel. Petrol and diesel, they are used in the automobiles. Their main disadvantage is when it is burned, it will produce some smoke, or it will produce some harmful gases that will be released in the atmosphere. So that's all today's portion, children. So about fuels, you have to learn about the definition for fuel, examples of fuel, then characteristics of fuels, types of fuels, solid, liquid and gaseous fuels. Then you should know the values of important fuels and their calorific values. And the main question is the important characteristics of an ideal fuel. That's all today's portion. Thank you, students.